Alright, so back at it. I've had a little break. I had another classes that I had to go to, and then my classes are over. It's the end of the day, and I can get back to writing code. And so at this point, what have we got? We've got a nice little app that has a rubber band line I can click and I can drag out. So at this point, let's see, what have I got? I've forgotten. We've got our imports. We've got a class fireworks that extends JFrame. It implements mouse listener and mouse motion listener. It's got a main class that just takes care of all the standard stuff. It's got a constructor that sets a flag mouse press to false. It adds a mouse listener, adds mouse motion listener. We've got event, mouse event, pressed and released that are going to store the location that the mouse was when it was pressed and released, and a Boolean that tells us whether the mouse is currently pressed down or not. We've got the width and height of the applet. We've got a paint method. Sets the color to black and fills the background. And then if the mouse is pressed, sets the color to white and draws a line from where it was pressed to where it's released. In the mouse press event, we just store the location of where it's pressed and set mouse press to true. In mouse released, we set mouse press to false, and we repaint. When the mouse is dragged, we set the release location to wherever the mouse is at the point when the mouse dragged event occurs, and repaint again. What we would like now is to be able to create particles when we release. A particle is going to move across the screen, so it's going to have a position. We're going to store those in doubles, X and Y. It's also going to have a velocity, a speed at which it's moving. It's going to be Vx and Vy. We're going to have a constructor that initializes X, Y, Vx, and Vy. So it's public particle double X double Y double Vx and double Vy. This dot X equals X. This dot Y equals Y. This dot Vx equals Vx. This dot Vy equals Vy. Just initializing all the instance variables. We're going to need to be able to update a particle. And when you update a particle, its position changes. So I'm going to say public update X plus equals Vx. So each time you update, we're going to update in a cycle. We're going to repeatedly update every 30 milliseconds or so. And if Vx is really big, it means the X position is going to change really fast. Vx is the velocity of the particle in the X direction. Y plus equals Vy, because we're going to change the Y position based on the velocity in the Y direction. We're going to need to be able to draw a particle. Public void paint. It's going to receive a graphics G. Now we're going to need to set the color. You know, I'd like my particles to all be different colors. I'd like to choose those colors at random. So I'm going to make a private method that returns a color, and I'm going to call it random color. And I need to create 3 floats. One for the red value, one for the blue value, one for the green value. Float R is equal to some float math.random. So it's going to choose a red color at random. Whoops, I got to spell random right. R-A-N-D-O-M. Math.random returns a double, but when we create a color, we're going to need 3 floats. I've got to import color. we're going to choose our other two color values the same way. So I'm just going to put my cursor here, hold down Shift, tap the down arrow so that I can highlight one line, hit Control C, and then hold down Control and tap V 3 times. And so now we've got our red, green, and blue values chosen at random, and we can just return some new color made from those red, green, and blue values. So each particle is going to have its own color. We'll call it my color. And then in the constructor, we're going to set my color to some random color. We're essentially calling the method random color. It'll generate the random color, return it, and then it gets assigned to the instance variable. Now that the particle has a color, we can paint it in that color. G.setColor, my color. Once we've set the color, we can draw it. G.filloval. The X, Y, oh, and we need a width and height for our particle. What I'm going to do is I'm going to just say the width and heights are the same. I'm going to say private double size. That's the size of my particle. I'm going to just start my size out at, oh, I don't know, 5. And when I update the particle, I'm going to make them shrink. I'm going to say size minus equals, oh, I don't know, 0.1. My update method right now is going to return void. And now when I fill my oval, I'm going to fill it size for my width and size for my height. Now size is a double, so we need to convert it to an int because fill oval is expecting ints. X and Y are also doubles. I also need to convert those to ints. Okay, so I've got this particle class. I can create a particle that has a position, a velocity, a color, and a size. Its color was chosen at random. Its velocities were set in the constructor. Its size was set to 5. When we update it, we change its position based on its velocity. So now back to our fireworks application. I want to keep track of a bunch of particles. So I'm going to say private array list of type particle. I'm going to call it all particles. In the constructor, I need to import array list. In the constructor, I need to initialize that array list to an empty array list. This only declares the variable. So I have to, in the constructor, actually create the array list object. All particles equals new array list of type particle. Now when I release, I want to create a new particle, yes? So mouse released. I want to say something like, okay, I want to create the particle at the place where the mouse was released, yes? So it was released at e.x, at the get x of e. So I can say int x equals e.getx. And int y equals e.gety. Now my velocity is going to be determined both by where I press and where I release, because if I press and release far from where I pressed, then I want it to go really fast. But if I release really close to where I pressed, I want it to go slow. So I can say something like int Vx is going to be equal to, let's see, final minus initial, and x is holding my final, minus pressed dot get x. And int Vy is equal to y minus pressed dot get y. Now I need to create a new particle using x, y, vx, and vy and add it to my array list. So all particles dot add new particle x comma y comma vx comma vy. So that'll add the particles to the array list. I want to be able to draw all my particles. So inside of Paint, I want to do something sort of like, for each particle P that's contained in all particles, P.paint using graphics G. So this may act a little bit funny because it's not, we may get our particles and it may show something, but it may not be exactly what we wanted. The particles aren't moving. They're just being created. How do I get them to move? I got to call that update somehow that moves them. And I've got to call it again and again and again and again. How do I do that? All right, so in any kind of animation, we have to have some sort of an animation loop. Some method, some loop that keeps executing the same code over and over and over, and each time it does, it calls update on all the objects that are moving, and then repaint to repaint them at their new locations. So the way that we do this is we make our J-frame runnable, okay? So it's got to implement the runnable interface. And it automatically imported runnable for us, I guess. But we've got to add the unimplemented methods. Whenever we implement an interface, we've got to add the unimplemented methods. And the unimplemented method for the runnable interface is run. Since we want this thing to go forever, we can just say while true. True is always true, and so it's going to keep going through this as long as true is true. It's just going to keep going through this over and over and over and over again forever. Inside of this loop, we want to update all particles and then repaint. And then we want to wait a little while. The reason why we want to wait a little while is because if we just keep going around this thing as fast as we can, we're going to tie up the processor on the computer. You'll hear your fan go on, and nothing else is going to run very well. Not only that, but some computers are faster than others. And if we go around this as fast as we can, we're going to update as many times as your computer can do it in a second. Some computers would then move things faster than others. But if we wait a fixed amount of time, then that fixed amount of time causes all computers to sort of run at the same speed, essentially. And so our game will run at the same speed regardless of what computer it's being run on. Not only that, but when this thing is waiting, it allows other things to be going on our computer so it doesn't tie up all of the other resources of the computer. So the way to wait, well, we saw that when we were trying to debug the last program. It was a thread.sleep. And I like to sleep about 20 milliseconds. That seems to be just enough to give us a nice smooth animation. Whenever we thread sleep, it asks us to surround that with a try-catch, and we just do that. That's fine. Now, for all particles to update, we want to do a for each loop. For each particle, P that's contained in all particles, p.update. And then for repaint, what I'm going to do is I'm going to say something like this.paint, this.getGraphics. I could just call repaint, but the method where I call paint and getGraphics gives me a little bit better results. We will have to be a little bit careful. In any animation we could have flickering. We're going to have some flickering. But for now I'm not going to worry about it. This should give us some sort of animation. We've got a few other details to worry about, but I just want to run this and see what it does. Do we get moving particles? So if I drag and release, I don't get any moving particles yet. What's going on? Oh, just like we had to add mouse listener and mouse motion listener when we implemented that interface, we've got to do something in the constructor to get that run method going. Okay? To get that run method going, we're going to say new thread this dot start. That'll get that thread going. So when you create a new thread, you have to pass the constructor something that implements runnable. It has a run method, and then when you tell that thread to start, it starts executing that run method independent of anything else that's going on in the program. And so it's going to be running, and while it runs, everything else in the program is going to keep going. So this constructor comes back immediately, even though this method will never finish. It will keep going forever, but that doesn't lock up our program, because creating a thread and telling it to start doesn't stop the constructor. The constructor completes immediately, even though that thread is still going in that at the same time. All right? So now hopefully that run method is going to be going. And it's not, because we had a null pointer exception. What's wrong with that? Null pointer exception in paint. So one of the challenges is that normally paint doesn't get called until the constructor is finished. Once the constructor is finished, we have a graphics object. But at this point, when this thread starts, we don't yet have a graphics object, so paint will get called with nothing. We can stop that crash by just saying if g equals null, return. So the paint method is going to quit if it gets called too early, essentially. I still got a crash. I don't like that. What's going on? G is not null. I wonder if all particles is null. It shouldn't be. Nope. I know what it is. Mouse pressed. Mouse pressed is now getting called right away. It's not waiting. So repaint is getting called before we release. We've pressed. Mouse pressed is true. We've set pressed, but we haven't set the released event. I'm going to just go ahead and set pressed released equals pressed equals E. That should fix it. I'm also going to get rid of this all particles equals null thing. That was just a shot in the dark. Haha, I can shoot particles. Isn't that great? That is awesome. This is a huge step. Alright. But they go really fast, yeah? They're hard to see. You may not even see them in your video. Let me make them really big. Particle. Instead of making them 5, I'm going to make them 15. Haha, and you should probably see that, but they're still going way too fast. So let's slow them down a bit. In fireworks, when we release, instead of setting the velocity to the distance, I just want to take this Vx and Vy. I'm just going to change these to doubles. And then I'm going to take my Vx and I'm going to just, divide it by 5. And Vy, divide that by 5 as well. So it's just going to go 1/5 the speed it was going before. I think that might be a little bit better. Oh yeah, that's much better. Now my particles are kind of dark, and they might be a little bit hard to see on that black background. I'm going to make them a little bit lighter in color. So when I choose my random number for red, green, and blue, the bigger these numbers, the lighter the color. This is a number between 0 and 1. If I divide it by 2, now it's a number between 0 and 0.5. I'm going to add 0.5 to that, and now it's a number between 0.5 and 1. I don't want a number bigger than 1, but I don't want a number that's smaller than 0.5, otherwise it could be pretty dark. So I scale it down and shift it up. So now the differences in colors is pretty subtle, but they are different colored. And they are all sort of close to white. That's good. Now, what I'd like to do is I'd like to be shooting projectiles, and for my projectiles to explode, I'm going to make my projectile extend particle. Okay, we've been using extends inside of fireworks, or inside of applets when we extended a J-frame. When we extend a class, we inherit all the public methods of that class. So particle has a bunch of public stuff, right? Public update, public paint. It's also got a constructor. Constructors are a little different. If particle has a constructor that requires parameters, then projectile, if it extends it, is also going to have a constructor that requires parameters. And so Eclipse is kind of suggesting that we add that. This super thing, basically the constructor of projectile is going to call the constructor of particle and just do what the constructor of particle did. And that's exactly what we want, okay? Our projectiles are going to be very similar to particles, but just a little bit different. And rather than rewriting the code, we can just have them extend particle and then add some extra behavior to it. Just like our fireworks extended J-frame and is just adding extra behavior to the J-frame class that already exists. So now instead of creating a new particle, we're going to create a new projectile when we release. New projectile. And you might say, okay, I've created a projectile and put it in this array of particles. But I thought a projectile was a projectile and a particle was a particle. They're two different classes. Well, projectile, because it extends particle, is what's called a subclass of particle. Anything that is a subclass of another class. A projectile is a subclass of particle, is a child of particles. Therefore, we say a projectile is a particle. Another example of a subclass would be, say, like dog and pit bull. A pit bull would be considered a subclass of a dog because a pit bull is a dog. You don't say that a dog is necessarily a pit bull. Not all dogs are. but a projectile is a subclass of particle. Pitbull may not be the best dog to use as an example. Maybe Chihuahua or Poodle would be other subclasses. Not every poodle is a pit bull. Not every, well, poodles are never pit bulls. So you can have multiple subclasses. I could create another class that is not a projectile, but extends particle. I could have as many classes as I want extend particle. But projectile can only extend one class. A poodle can't also extend a cat. The extends thing can get a little complicated. If you don't fully understand it at the moment, that's okay. We'll just see more examples of it, and eventually it'll come together. So now everything should just work the same at this point, because projectiles act and look at this moment exactly like particles. Now, I'm going to modify the update method a little bit, because I would like to know if the size gets too small. When the size gets down to something really small, I would like to make it explode. I'm going to start size back out at 5 again, because I think it's going to look a little bit better in the end. So I'm going to make update return a value. I'm going to make it return a Boolean. And then I'm going to add a return statement. Return size is less than 1. So every time we update, the size decreases, and eventually it's going to get down to 1. So it keeps returning true every time we update until size reaches 1. When it's smaller than 1, it's going to return false over and over and over again. Then eventually it'll return true, because eventually its size is less than 1. Now down here, when I update in the run method, when I update all my particles, I want to do something. I want to say if when I update it, if it tells me that its size is less than 1, then I want to remove it. I want to say something like all particles dot remove P. Now that's useful. Our size keeps decreasing, but we keep adding particles into this array list, and we always update all of our particles. If we never remove them from the array list, that array list keeps getting bigger and bigger and bigger, and this update method, where we're updating all our particles, will take longer and longer and longer until eventually our program stops running. We have to eventually remove the particles from the array list so that the size of that list doesn't get too big. Okay, so the other thing I would like to do is I would like to say if that particle P that just got down to a size less than 1 is an instance of projectile. So some of those particles are just plain old particles, and some of them are projectiles. And I want to do something different with the projectiles. I want to make them explode. Okay? So I want to cast that. I want to say something like treat P as if it was a projectile. And then make it explode. Okay, at this point it's saying projectiles don't have an explode method. Do you want to add one? Oh yeah, I do. And so it's adding an explode method to the projectile. What do I want it to do when it explodes? I want it to explode into lots and lots and lots of particles, okay? So what I'd like to do is I'd like to return an array list of particles. And that array list of particles is all the little pieces that the projectile exploded into. So I'm going to create a variable that is an array list of particles. and I'm going to call it pieces, because that's all the pieces of the projectile. And that's going to be equal to some new array list of type particle. Now I have to import array list into this class because I haven't added it yet. And now I want to add a bunch of new pieces or particles to that array list. I want to say something like for int I equals 0, I less than, oh, how many pieces do I want? I want like 100 pieces, a whole bunch of them, I++. And then I want to say pieces dot add new particle. And I want this new particle to be created at my location, x comma y. And what am I going to do with the Vx and the Vy? Okay, I'm going to modify my particle thing a little bit. We'll see this in a second. This is going to, because I want them to be at Vx and Vy, x and y, but I want them to go all over the place. Actually, let's do it this way. I'm going to put a squiggly bracket here. And I want it to be my, so if I'm a projectile, I've got some velocity in the x and some velocity in the y. I want some other new velocity in the x. So I'm going to say double Vx equals math.random, oh, I don't know, times 5. Now this is going to look a little funny at first, but we'll fix it. And double Vy equals math.random times 5. And then I'm going to pass that Vx and that Vy that are different. Say I'm a projectile. I just exploded into a bunch of pieces that all start at my location, but with random velocities going just all spraying out, okay? So that's going to create a bunch of particles with random velocities, stick them in this array list of pieces, and then I just want to return that array list of pieces. Alright, now that I've got that array list of pieces, oh, there is no class called particles. I can't have an array list of particles. I can have an array list of particle. That's something that I do. What's this? Okay, x and y. X and y were declared inside of particle, not projectile. The projectile has an x and y, but I don't have access to them. Why not? Because inside of particle I declared them as being private. Private variables are only accessible directly from between the squiggly brackets. But I would like to be able to get at them from projectile. I don't really want to get at those from fireworks. I still want to limit their accessibility. It's always a good idea to limit the accessibility of things as much as possible. And up until now, we've only used public and private. What I'd like to do now is I would like to make the x, y, vx, and vy protected. So if something's private, it's only accessible within the class. If it's public, it's accessible from everywhere. If it's protected, it's accessible from anything that's within the family. Okay? So you protect the family. So a projectile is within the family of particle. It's a child of particle. It's a subclass of particle. So now that it's a child of particle, it has access to all the protected members of the particle class. And that got rid of my little error here saying that it didn't know what x and y were. So now if I run this, it's not going to do anything different. Why not? Doo-doo-doo. So I don't see anything. Oh, but I get a crash. Oh, that's not good. What happened? Concurrent modification. Here's the deal. we've got this multi-threaded application, okay? Multi-threaded, it means multiple things are going on at the same time, okay? And we've got this array list inside of particles that are being added to and removed from, okay? Is being added to and removed from inside of this run thread, but it's also being diddled with inside of paint. And that's a bad thing. Because if paint is in the middle of trying to paint a particle and that particle is just immediately removed, well, that causes a crash. So how can I prevent that? I can prevent it with a lock. So there's another object that I need. It's called a semaphore. I'm going to create a private semaphore that I call lock. Okay? And I've got to import the semaphore class. So what I would like to do is I would like to protect my array list of particles. So whenever I diddle with it, it just locks out everybody else. Now inside of the constructor, I've got to create the lock because this just declares a variable called lock, which is a semaphore. So I'm going to say lock is equal to new semaphore. And I'm going to give it a 1. What that means is a semaphore is something that I can acquire and release. And if when I create it, I say 1, that means only one thread of execution, one thread, one thing can acquire the lock at a time. And so now, before I diddle with my array list of particles, I'm going to acquire the lock, and then when I'm done, I'm going to release the lock. And if some other thread tries to acquire the lock while some other thread has it, the thread that's trying to acquire it will wait until the other thread releases it, and they won't diddle with all particles at the same time. So, before I go into this loop, I'm going to say lock.acquire. So it's grabbing the lock. Now, whenever I try to acquire a lock, I've got to put that into a try-catch. When I'm done diddling with it, I say lock.release. And then up here in Paint, I also diddle with my array list. So I'm going to say lock.acquire. Surround that with try-catch. And then when I'm done with that, I'm going to lock.release. That'll prevent this crash from happening. Oh, didn't do it. What happened? So when it crashed, it tells me concurrent modification in the run method at line 110. So I'm going to double click on this. Did I not acquire a lock? That's not good. Oh, I know what I did wrong. I'm using a for each loop. There's a problem with for each loops. They have a little bit of a limitation. Whenever I loop on a container class, I can't add or remove things, add things to or remove things from the container while I'm going through it on a for each loop. So I've got to change this a little bit. I'm going to change it to a regular for loop. I'm going to say for int I equals 0, I less than all particles dot size I plus plus. And then I'm just going to say particle P equals all particles dot get I. Okay, that'll fix that crash. All right, so so it's running, but I don't see any explosions yet, right? That's because we have this, if it's an instance of the projectile explode, this explode method is returning a lot of pieces, but we don't do anything with them. We need to add them into the list of all particles. All particles. Instead of add, we're going to say add all. Because we want to add all the little pieces at once. Let's see what that does. This should be interesting. Pow! All right, we got explosions. They are funny looking explosions though. They're square. And they always go down and to the right. That's because down and to the right are positive directions. And when we calculated our velocities in projectile, we only gave them positive velocities. So if I say times 5 minus 2.5, now the range of my velocities is anywhere from negative 2.5 to positive 2.5. All right, well that's a little bit better. They're still going to be square. Pow! And, you know, they don't look terribly square, but just a little square. Nobody wants to be square. If we add more particles, say like 500, now they look really blocky. And you notice that it kind of flickers a little bit. If I kind of spam this thing, oh, if I spam it, it crashes. That's not good. When I spam the button, oh, and this thing's running, it's locked up. If this thing locks up real good like this and the X button doesn't work, you can always just hit the red dot down here. Bam, it's closed. I want to try this again. All right, what's crashing now? Thread.run, fireworks run. So I'm looking at fireworks.run, Java line 120. Paint.get graphics. That's really strange. What is going on? I have not had that before. So inside of paint line 51. Oh, that's interesting. In lock release. I wonder. I wonder if I'm successfully acquiring and releasing those locks and protecting that critical section. That's really strange. I have not had this problem before.